Question 16 has us reviewing the properties of a parallelogram. Okay, so the two big properties that you want to remember specifically in for this question is that opposite sides are congruent. Okay, so to find the value of A, we know that T, S, and VW are congruent. So we just set the two expressions equal to one another and solve for A. Okay, so subtract A from both sides. Remember, there's a 1 in front of it, even though we don't write it. So we have 2A plus 11 equals 15. Subtract 11 from both sides. We get 2A is equal to 4. And when I divide both sides by 2, A equals 2. Okay, so we're going to do the exact same thing for B. TV and SW are opposite sides, so therefore they're also congruent. So 3B plus 5 equals B plus 11. Subtract 5 from both sides. I get 3B is equal to B plus 11 minus 5 is 6. Then subtract B from both sides. And yes, I did the constants first before I did the variable. It does not matter. I was just changing things up a bit because I'm sick of doing the same thing over and over again. So 3B minus 1B is 2B. When we divide both sides by 2, B equals 3. Okay, so that's the big property for parallelograms, knowing that opposite sides are congruent. Here, we have a rectangle, all right? And the thing to remember about a rectangle is that it is also a parallelogram, so opposite sides are congruent, but also their diagonals are also congruent. So FH is equal to EG. Okay, now reading the question, if the measure FEG, so FEG is 57 degrees, find the measure of GEH. Oh. Okay. Well, this is easier than I thought because angle E, actually all the angles in a rectangle are 90 degrees. So with the diagonal cutting angle E into two smaller angles, if one of the angles is 57, and we know the whole angle is 90, we just subtract 90 minus 57. And we get 33, I believe, if my mental math is correct. And it is. So the measure of GEH is just 33 degrees. Okay. Next, we're looking at dilations. Okay. And this is a precursor to our unit on similar figures. So we want to determine whether the dilation from the figure on the left to the figure on the right. So we're going from small to large. So we're going from A, B, C, D to L, M, and P. So it's getting bigger, so obviously it's an enlargement. Okay. So we can cross out A and D. And if we look at the two side lengths, what number times 6 will give me 18? 4 times 6 is 24, so that's not it. So it has to be C. 6 times 3 gives me 18. So the scale factor for this particular problem is 3. And all the sides, remember with a dilation, all the sides have the same scale factor. Okay, so moving on to similar figures. It says determine whether the figures are similar, and if so, find the scale factor. Explain your reasoning. Okay. Well, there's two things that determine whether two figures are similar. First, they have to have corresponding congruent angles. All right. So what that means is that in triangle WYZ, there's a 39-degree angle. There is no 39-degree angle in triangle KLM. So my first instinct is to say no. This can't possibly be similar figures. Now, but just to be sure, the other way we can confirm is to check the scale factor. Okay. And unfortunately, we can't even, it would have been nice if they had given us a similarity statement. Okay. Because we know Z is congruent to K. And what we have to do is I have to redraw, because KLM is rotated. So to get it so it's in the same orientation as WZY, I have to rotate this so L, I'm trying to envision rotating KLM. So after rotating triangle LKM, I can now match up the side lengths to determine if the scale factors match, okay? So 7.4 corresponds with 5. 11 corresponds with 6.4, and 8.2 corresponds with 4. Okay, so if I divide 7.4 divided by 5, I get 1.48. If I divide 11 by 6.4, I get 1.72. And if I do 8.2 divided by 4, I get 2.05. So you'll notice I get a scale factor, a different scale factor for every side length. So our only option is no. The two triangles are not similar. Our next question says, fill in the blanks using the available answer choices. Identify the similar figures and find the value of x. Okay, so you'll notice that the triangles are in different orientations. So I'm going to try to turn the smaller triangle so that my right angle is at U. So if I 1, 2, as you can notice, my spatial relations are not great. Okay, yeah, so, but I do know that my hypotenuse, which is across from my right angle, is 5. So then UV is 4, and then this is 3. So if we have RST, R corresponds with the U, because that's also a right angle. W, S is listed next, so that's V. And then T is my last letter, so that would be W. So that would be my similarity statement. Remember, the corresponding congruent angles have to be in the same order. Okay, so then from here, now that I know how the sides correspond, my hypotenuse, obviously, that was what I'm trying to solve for, my larger triangle. And just because I want to, so I could use either 3 and 6.75, or I could use 4 and 9. It doesn't matter which one you use because we have both values. I like whole numbers better. So I'm going to set up my proportion using 4 and 9. Okay, now remember, I listed the values of my smaller triangle on top. So that means all of my values for my smaller triangle have to be in the numerator. And everything in my, from all the lengths from my larger triangle have to be in the denominator. Okay, so from here, we are just going to cross multiply to solve. So I'm going to get 4x equals 45. And when I divide by 4, I get x is equal to 11.25. And that is this answer here. Our last question on similarity is this triangle here where we have, it shows us that the two bases are parallel to one another. And what that means is that the smaller portions between the parallel lines are proportional to the top. Okay, so I can simply set this up as 20 over x equals 18 over 9. And of course you can cross multiply and solve for x. So we get 18x is equal to 20 times 9, which is 180. And when you divide by 18, you get 10. Now, you could also simply notice that 9 is half of 18. So half of 20 is 10. So if you have nice whole numbers where you notice the relationship between the one pair of sides, you can also just apply that same scale factor or that same relationship to the other side as well.